Okay, I want to welcome everybody on tonight and those who will watch this later on. You're in for a treat tonight. Chip Osborne, I've known, I don't know, over 15 years or so. He is probably the um, well-versed person to not only discuss organic lawn care, but also to implement it. He travels the country doing all kinds of projects. Has done a lot of work with the U.S. Parks Service and non-toxic communities, and it's just a wealth of information. So, Chip, I want to thank you so much for taking the time out to spread some of your knowledge, and the floor is yours now.
Well, great. Well, thanks, Barry, and thanks for thinking about me as part of this this series that you're doing and bringing education, to the to the masses and making it available. And one of the it's funny where here in the company I'm sort of succumbing to the social media age, and we're beginning to have a concerted effort, and I got to come up with all these little quotes and things to be releases. And one of my favorite ones is the more widespread adoption of organic land care practices and principles is simply limited by the lack of quality education that's out there. And my hat's off to you for the initiative to bring a wide range of subjects over the course of the winter that include availability of product and as well as practices and strategies. So that is really what the industry needs. So what I'm going to talk to you all tonight, I know I'm sure on here tonight there are people that are versed in organic land care, skilled in organic land care. In fact, Rick is on here and knows as much, maybe more than I do. So it's really a whole bunch of people that have worked over a number of years to develop successful strategies, or what I call steps for success. So I'm going to give a high level overview of what has worked for me. And then I'll show some pictures of a wide variety of situations and projects that, natural turf management and organic land care has stepped in and, been the foundation and for change and foundation to transition from conventional into natural strategies. First step is we understand why we're doing this. So I know we didn't just wake up this morning and decide that this would be a great thing to do. There's reasons. And for me, 25 years ago, or even a little bit more now, I had reasons. And I had reasons because I'm a 50-year horticulturist, and I spent 20 plus years using pesticides and chemicals in greenhouse production and landscape nursery production, and probably used more pounds of active ingredient than most people, out in the world of land management use. And it's a human health and environmental issue. It's also an issue when you get an understanding the US EPA and the registration process as outlined in FIFRA. And the bottom line is that there are huge flaws in the pesticide registration process. We are still using information that was created in 1972. And we still evaluate pesticides under the model of risk assessment. And that risk assessment model is totally outdated because it's based on acute exposures. Acute exposures only to an active ingredient, not inert ingredients, and not minute exposures. And all science and medicine now points towards the fact that it is the low dose exposures cumulatively over many years that potentially is the greater problem. So we understand that. There is a reason that people are looking towards this. Questions that come up right off the bat are these questions. What is a pesticide? What are synthetic fertilizers? Does the law protect us? The short answer on that is no, it doesn't. What are the health risks, the unique vulnerability of children, environmental risks, and what do we do to reduce and eliminate exposures in our lives? So this is what your clients are being exposed to. And we know nowadays that you can't pick up any kind of media, virtual or print, that in some place, some day, some week, somebody's not talking about alternatives and organic food and issues with personal care products and the whole toxic cloud that we live in. So that's what your potential clients are hearing. Our response in the industry in developing alternative management practices seeks to directly address that issue. So as I mentioned, science, risk assessment, LD50 acute doses, not written in, not aligned with newer research, public health, children's health, pollinator health, pet health, environmental health. These are all the issues that our potential customers are being exposed to, and others have, some have strong, leaning in one of these and some in more. So people intersect with this issue in very different ways. The bottom line, when we were doing this in the 1990s, not everybody agreed about the use of synthetics. And in fact, it was a battle, very often. The fact is that doesn't even matter anymore, whether everybody agrees about the use of synthetics. The bottom line is that there is a changing market. And, 20 years ago, we said someday the market will change. And when the market changes, practices and products change. Right now, we're at that tipping point. There is market opportunity in this industry for somebody to make a pretty good living. I look at it as pesticides generally treat symptoms. They do not grow landscapes. So they're not problem solvers. So if I have crabgrass in a lawn, that's not the problem. That's a symptom. And I have to identify what that underlying problem is. If I have a fungal disease in turf, that's the symptom manifesting itself because there is an underlying problem. And it may be in the soil, it may be that it's being irrigated too much, it may be that it's too shady, any one of a number of things. But in order to make those symptoms go away, I have to identify and address the underlying problems. And that may be done with product, or it may be done with cultural practices. I follow the guidelines of organic integrated pest management. There's research out now that the new studies now that show that IPM, as written 25 years ago, never has achieved its goal. It did not achieve the goal of pesticide reduction. So under a lot of IPM plans and programs, pesticide use has remained the same or even increased. Now, granted, the toxicity of an individual active ingredient may be less than it was 25 years ago, but the fact is, under IPM programs, there is still liberal allowance for the generally widespread use of synthetics. In an organic IPM program, soil health plays a critical role, and soil health is not addressed in traditional IPM. We have different product choices at the end, either US EPA 25B or OMRI certified. And if we follow an organic IPM program and we do it properly and we focus on soil health, costs decline over time as the system moves towards sustainability. When I intervene with an allowed pesticide, I am looking at that as a rescue treatment. I typically am not scheduling those in by the calendar date, but relying on 25B or OMRI certified control products as might be needed. It really is about managing expectations, and we'll talk about that a little bit more detail. In a conventional or organic program, a low level of input is low cost and it meets low expectations. Higher level of input, higher cost, and that's what it takes to meet higher expectations. So this is true in any kind of a program. Think of the 4-step program. If you buy all 4 bags, you get an expectation. If you only buy 2, you're likely going to get a very different expectation. Cultural intensity is how we describe everything that goes into meeting an expectation. So when we when we work with a client, and first thing we want to know is, what are your expectations? What do you want to get out of this organic lawn care program? Where do you want to be on the scale of high to low expectations? Then our job is to create a program of some degree of cultural intensity that is required to meet that expectation. The other thing that is not in here, should probably say, there is water. Because as we know, to grow anything, water is critical. Now, grass will survive without irrigation, and in a drought situation, it will take itself dormant in order to protect itself. But in order to get good, active, relatively lush growth, there is water required. So input, water, and labor is cultural intensity. So my focus and the way I've developed my management strategies are what I call a systems approach to turf management. 3 distinct concepts: basic understanding of soil biological life, what is happening underground. I'm not saying that everybody has to be, a biologist and a scientist to make this work, but a general understanding that there's living organisms down there and one guy is consuming another guy, and the end result is nitrogen in a plant available form. The exclusive use of natural organic product as dictated or as governed by soil testing. Now, I fully understand that in not every land, not every practitioner is going to soil test every lawn, although I think that's a great idea and it's something that should be passed on to the client, and the client is willing to pay for in most cases. But in the absence of individual soil testing, at least testing composites of a number of samples in your service area to understand more or less what is happening with soils in that region. And then revised cultural or horticultural practices, things in a conventional program that tend to get put to the back burner because interventions with synthetic water soluble nitrogen and certain control products can override cultural practices. In other words, can be employed in the absence of good cultural practices. So we need to have a renewed focus on soil health. So this is where I start. Addressing the soil and the biomass is central to success. Conventional management tends to be product-centric with minimal focus on soil health. So if we try to approach organic lawn care with a product approach, we're probably going to fail because we're missing the picture, the big picture of the systems-based approach. So just swapping, conventional product for organic product, no matter what that might be, is really only a part of it. And if we make that the sole focus, we're likely to not meet with any real degree of success. Basic soil biology. So I get way more involved than basic biology. I mean, every project, I don't involve myself in any project right now where they're not committed to do a $350 battery of soil testing. Now, these are big projects, and it's one of those things you're certainly not going to do that for every homeowner. But I would encourage any practitioner to do 1 or 2 or 3 soil biological assays so you can get an idea again on what is happening in soils. And different regions of the country have very different biological fractions at play, and very different things are happening. And there's a lot of regional variability to that. So getting some kind of an understanding, if for nothing else other than your own information, to guide you in how best to structure a program. So nature's put everything in place we need there to do it, and our job is simply to optimize that. I always look to mimic the natural ecosystem in a managed landscape, and I'll show you a picture of a high-profile baseball stadium. And I'm as crazy as it sounds, my focus on that is trying to mimic what's happening in nature, even though this is a very unnatural environment. Most important to address both above and below the ground. Probably one of the best compliments I ever had was out in Ohio, and I did a 3-hour training for a parks crew. And we went through in pretty good detail all of the things I'm hitting for the high level overview here tonight. But when we walked out on his park, and it was at a park headquarters, and the park was on that grounds, and we walked out and he said, for the first time, I understand what's going on under my feet. And this was a guy that was a golf course superintendent and had been working golf for 15 years. And then he went to work for his local park department. He'd been there 10 years. So he really knew his stuff. He was a really good turf guy, but he never had really been taught or trained to focus on what was happening under his feet. We remember that if we have a healthy plant, a healthy grass plant, we can often, put in the process of when the plant is making its own food energy, 80% of that energy goes into the root system. And half of that goes into the roots and is released into the soil as an exudate. So the idea that just by managing our lawn organically and getting it healthy and allowing it to go through the process of photosynthesis in a very efficient way, it is actually producing food for the microbial community, and that's food that we don't have to pay for. So when I develop a turf management program, half of my input goes to meet the immediate needs of the turf grass. The other half of my input is really focused on stimulating some aspect of the soil biological community. Excuse me. So that is really my two-pronged focus. I was given these slides by Penn State 15 years ago. And they proposed back then that conventionally, we have been taught to look at soils as three individual areas: soil structure, sand, silt, and clay; soil chemistry, pH, organic matter, cation exchange, base saturation, macro, micronutrients; and then the soil biological fraction, that some fraction of that soil is biologically active. But in conventional management, we don't look at these as anything other than three unrelated areas. So in conventional management, almost the entire focus is on soil chemistry. Very little on texture, structure, and almost nothing on the biological fraction. Penn State proposed at the time that we should be looking at soils like this, that there is an intersection between structure, chemistry, biological life, and where those areas intersect is what they coined, and Penn State coined the term soil health. The idea that if we can integrate these soils, and we're not going to change, by the way, soil structure, texture, gradation analysis. Sand, silt, and clay is what it is. So I don't go to work in Arizona or Florida or Southern California and try to change that soil to match New England or Ohio or Wisconsin. I'm working with the soil that we're given to the best of the ability that we can create a program. So we're not looking to change soils to match soils in other regions of the country, but just to improve soil structure, soil function, therefore soil biological life, to create this healthy environment. I can't stress.
Chip, I was just going to ask a quick question. We have a couple questions in the chat.
Sure. Yep.
John Raffiani would like to know, does organic lawn care make the host part of the disease triangle stronger?
Oh, absolutely. And that is a very good question. And that's exactly what we're doing. When you look at the disease triangle, you have to have a host, and you have the 3 points on the triangle, and then the fourth dimension is time. That is exactly what we're doing. My definition of organic is putting a series of preventative steps in place so that problems don't get out of control. And that's exactly what we're doing when we're improving the health of the host and making it so that it can ward off or stand up to fungal pathogens without product intervention on our part.
He's got an additional question, and I think you're going to answer it a little further, but let me ask it now. You can answer it as you see fit. It says,
Sure.
Please address further the steps to wean soil and turf off chemicals and into organics.
Yeah, the steps, I will address that. And as I go through here, but the steps are, the first step is soil health. Absolutely the first step. So, well, actually, let me back up. The first step is to stop synthetics. Because if we are using synthetic fertilizers, they generally, for the most part, have a pretty high salt index. So salt is not conducive to a healthy biological fraction. So in my experience, it's very difficult to have a full bore synthetic fertilizer program. I'm not talking about, the use of bridge products and I mean, I try to use natural organic fertilizers most of the time, and I do. Occasionally, I do have to fall back on transitional fertilizers, but I'm talking about the straight ammonium nitrates, the straight ureas. Those are salts, and mineral salts not conducive to a healthy system. So that's the first thing, is stopping synthetics, stopping pesticide applications. The biggest issue is pre-emergence, because you're going to stop pre-emergence. Now, maybe you get a flush of crabgrass, maybe you won't. But if I use pre-emergence, I can't use grass seed. So I have to make that decision. So again, building the health of the system, focusing on the soil, focusing on a proper fertility program that meets the needs of the turf grass. Fertility, I'll talk in a little bit about, is tied directly to expectations. So if you have high expectations, you can't go in low fertility. So you have to decide, so if you're running a lawn care program, you need to have 2 or 3 options, one to meet high expectations and one that meets a more modest expectation. So those are the first steps. Reliance on grass seed after the soil biological, reliance on the cultural grass seed I put in with cultural practices, and then just beginning a good, solid organic nutritional program. Any other ones, or is that good for questions for the moment? That good right now?
That's what we have for now.
All right,
Oh,
perfect.
wait a minute. Oh, we just had one come in under the wire. Would Milorganite be considered organic and of a low salt content? Excellent question.
Yeah, Milorganite is considered organic, but Milorganite is biosolid sewage sludge. So what we try to do with our organic programs is to have the material OMRI certified, or what I call organic or OMRI compatible, even if it may not be certified. Biosolids or sludge products are not allowed in organic agriculture. Therefore, by default, we do not put them into organic programs. Now, I know that there are some transitional fertilizers that have some organic fertilizer, legitimate organic source of nitrogen, and then some biosolid or some urea. That's the drawback to Milorganite. And the reason we don't like biosolids is metals. Milorganite doesn't test high in metals. But the other thing that is a concern to us is residual pharmaceuticals. And we don't know because that's not tested, but that typically appears in biosolids. So that's why we stay away from Milorganite.
Yeah, Chip, I'm just going to interrupt a little bit because the term organic gets used and abused all over the place. With agriculture, it's very clear what organic is, and it has to go through the OMRI listing and everything. But in the landscape, it's like the Wild West.
That's absolutely true, that there is many definitions of organic and organic based and variations on it, and what can be called organic. And I mean, technically anything with a carbon compound is organic. So yeah, it really is. You're exactly right, Barry. It's all over the place.
William Skerrick had an excellent question that I share. What about PFAS?
What about peat moss?
PFAS. The forever chemical.
Yeah. I mean, what do we want to know about that? Oh, that's contained in some of the biosolids?
Correct.
Yeah, no, absolutely. Yeah, all those issues. Just one more of those issues. Absolutely correct. Yep. All right, let me jump right back in. All right, so this is a pretty dramatic slide, and we tend not to look at things this way. I'm a bug on oxygen in soils. To me, that's critical. If I have a soil that doesn't have good structure, that is low on oxygen, I'm not going to do very well. My grass plant root is not going to do very well, nor is the biological fraction. So on the left is a national, on an average, 45% mineral, 5% organic matter fraction, and then 25% air and 25% water. So that represents a well aerated soil where there's good soil structure and good pore space. On the right is a compacted soil, and you can look how things change dramatically when the organic matter shrinks down to 6% and oxygen, air is down to 2% organic matter, 6% air, and can hold less moisture, and then the rest becomes that mineral soil. So I can't tell you, I bet you most projects I get involved in, the soil looks more on the right than it does on the left. And that has to be, again, one of my initial strong points of focus, is to try to get that soil on the right to look like that one on the left. Organic matter, I can't state enough how important the organic matter fraction is, how improving it is important. National average is 5%. Different lawns, different areas can be above or below that. When we're below that, we like to try to increase organic matter. And sometimes we don't have the budget, to go in and compost top dress, or we may not be set up as a company to compost top dress. So then we have to creatively figure how we can build organic matter. Well, one of the most passive and inexpensive ways to do it is to, again, manage the system organically, to try to grow that healthy, vigorous root system, knowing that our cool season turf grasses slough off a large portion of their root systems over the winter, which then ends up decomposing, breaking down, and being converted passively into organic matter. So a lot of ways that we can influence it. We can use a granular humate, we can use organic fertilizers, but the benefits are significant. Soil structure, solubilization of micronutrients, buffers the soil for pH, and then as organic matter decomposes, better aggregation, a direct nutrient release through decomposition, and improved biological activity. So when I get my soil test back, first thing I look at is organic matter. Second thing I look at is base saturation to see how my top tier macronutrients are there on the, at least for potassium, and then to a second tier calcium and magnesium.
Can
Soil
you put
testing.
Can you put the soil slide back up for a moment? I'm guessing someone here would like to take a screenshot of that.
Sorry about that. We good?
We're good.
Okay, so soil testing. If you choose to soil test, again, I don't do much of anything without it because that's my roadmap. Putting that probe or trowel down 3 or 4 inches, taking multiple samples, mixing them together, removing organic debris, letting the air dry overnight, putting it in a baggie and shipping it off to a laboratory. Just very quickly, 3 tests that we run: nutrient analysis, also known as soil chemistry. As I mentioned, pH, our grasses want 6.5 to 7. We get the organic matter. We get a ratio between calcium and magnesium. We get NPK, Cal, Mag, sulfur, micronutrients, and then CEC. Textural analysis, sand, silt, clay gives us a key to the soil's ability to hold on to nutrients, indicates a potential water holding capacity of the soil, classifies the soil based on the USDA textural classification, and can give us an indication of a tendency of that soil to become compacted. And then the third test is the expensive one. This is the biological assay of soil microorganisms. When we do this test, we want to leave chunks of the turf in there, because one of the one of the microorganisms we're going to test for is a mycorrhizal fungal colonization, endomycorrhizae. And we have to have roots involved in that sample in order to test that, because that is a microbe that has a direct root association.
Mike
So-
would like to know which labs you like to use.
I use Waypoint Analytical down in Richmond, Virginia for soil chemistry, soil texture. I use University of Massachusetts if I want to do a modified Morgan. Malik 3 laboratory, strong acid lab, giving you a full readout of what's in that soil. That's what Waypoint does. Modified Morgan is a weak acid extraction that gives you what's available, but not total. And then I use Soil Food Web New York for my biological assays. And then I use Woods End Research Laboratory down Maine for my carbon sequestration and soil health. They've developed a really neat test for about $100 that gives you a real snapshot of soil health and CO2 respiration, along with sequestered carbon in soils. So I kind of put those all together to form my suite of tests. Talk a little bit.
There's one more question. Can
Yeah.
you review the magnesium to calcium relationship?
Can I do what?
Can you review the magnesium?
Sure. Calcium to
calcium?
magnesium. So typically science tells us that we want roughly 7-to-1 to 8-to-1 ratio of calcium to magnesium. And that is found on the soil test in base saturation. So of those, of those cations that are adsorbed onto the exchange site, we want more calcium than magnesium. So we're not looking at the ppm on the test and running it that way, but we're doing it on base saturation. So when we look at base saturation, soil science, just traditional soil science, says that of the electrically charged sites in the soil, we're going to have some ammonium nitrogen on there. We're going to have some micronutrients on there, but of the macronutrients, we want 2 to 7% of those exchange sites occupied by potassium, 10 to 15% by magnesium, and 50 to 80% by calcium. So that is really our goal, and that is a balance. So what we're trying to do then is to balance the soil based on the numbers that are given to us in base saturation, always favoring, getting calcium to the higher side, because in the case of turf grass prefers more calcium than magnesium, although magnesium is essential to things like chlorophyll molecule and things like that. But the biomass also really is driven by calcium. Okay, so nutrition, fertilizers broken down into these 3 groups: organic based, and synthetic. So synthetic is a derivative of the Haber-Bosch process, the production of ammonia, which then we have, we have that process where it's reacted high pressure, high temperature, and the end result is 4600 urea. CO2 is involved in the process, natural gas involved in the process. And that is, there's a lot of cities now and their climate action plans where synthetic fertilizers are not going to fit into the equation moving forward, because it takes 5 tons of petrochemical equivalent to make and produce 1 ton of 4600 urea. I was just on a call this morning with Boulder, Colorado, and cities are just coming out and saying synthetic fertilizers no longer fit in a climate action plan. So that's the first time people have really started to talk in that kind of language. But that's sort of the way that is going. Organic based, as I said, is some organic and some of the other 2 there. And then organic fertilizers are where minerals, plants, and animal byproducts make up these fertilizers. Nitrogen, organic nitrogen source are plants, meaning grains, or again, animal byproducts, bones, feathers, fish, manures. The most important concept for fertility that I think I can give you tonight is sort of the real cornerstone of the way I approach fertility is there is no food for a plant in a bag of fertilizer. Even though we have bags that are marketed to us as plant food, lawn food, garden food, rose food, NPK is not plant food. NPK are catalysts, raw materials, and together with sunlight, water, carbon dioxide, enable the grass plant to produce organic compounds. So photosynthesis is the process where you put fertilizer down the lawn, you put nitrogen down on the lawn, and things happen to that grass. It grows blades, it grows roots, it grows horizontal extensions, and it gets greener. The green's the chlorophyll. Chlorophyll intensifies, reacts with energy from the sun, presence of carbon dioxide and moisture, microscopic openings, stomata on the underside of the leaves, open and close. CO2 goes right inside the plant. Byproduct is oxygen, and the other byproduct is carbohydrates and sugars, amino acids, and that is plant food. So through the process of photosynthesis, the plant's taking in CO2, giving off oxygen, and making its own food. And those sugars and carbohydrates, as I mentioned earlier, significant portion of them are exudates that go right down into the root system and out into the soil to stimulate the microbial community. So now I've focused on soils. I'm looking at the biological life. I'm understanding what is going on, who's eating who under there, how much nitrogen is being naturally produced, how much more nitrogen do I need to add to meet my expectations over what that soil is giving me. And I have some projects where I'm totally dependent upon a fertilizer bag in the beginning, knowing that if I manage the biological fraction correctly, I will be less dependent on that bag over time. Now, that doesn't mean if you're a practitioner that you're going to lose money if you're not putting as much fertilizer on. It means it's going to be more profitable over time. I had that discussion yesterday with some contractors, that you will be more productive and more profitable over time because you need to put down less to get the same result. So all my friends that are sells fertilizer in the fertilizer industry, I always apologize and say, I'm sorry, I'm telling people that it's going to be less fertilizer over time. But the good news is that if we get all the lawns in the United States organic, you guys are going to be so overwhelmed, you'll all be retired and have so much money, you won't know what to do with it all. So the idea that, we can reduce, but we can expand the concept. The third piece of the puzzle for me is the cultural practices. We understand that managing turf is simply about reducing and eliminating stresses. And any of these can be stresses. So our goal is to put that series of preventative steps in place so that we can get rid of these. Proper mowing goes without saying. I'm not telling you anything that you don't know. The optimum mowing height. And we didn't just pick that. That's based in science. Almost every university, cooperative extension that has a turf school, that has a website, will all tell you that 3 inches is the ideal stress-free height for managing cool season turf grass, because that's the height when everything is clicking. My experience, for every ½ inch a lawn is mowed below 3 inches, the cost incrementally goes up. And I manage, Kentucky bluegrass monocultures cut to 1 inch for high profile sports. And I can tell you the cost per 1,000 square feet or the cost per acre is way different than, what we're doing in any other aspect of turf management. Root to shoot ratio, and this is very true. What you have above ground is going to be reflective of what you have below ground. So those 1 inch heights that I have, they're not drought tolerant at all, because I've had a hard time with some people that, know turf and they want deep probing root systems, but the grass is being cut to 1 inch because of sports considerations, but they don't understand that I can't get a 6 or an 8-inch root system when I only have 1 inch of tissue. If you give me 3 inches of tissue, then I can push down there. So, important concept here. Grass is not a water pig, believe me. And as being a commercial grower for 37 years of a variety of different types of plant material, including turf grass, grass is, people tend to think that grass equals kindness. And I can honestly tell you from my experience over the years, not true. Too much kindness, meaning too much water, always causes problems for plants. So, good irrigation management, central to some of the successes. Paul Sachs, I always credit him with this, the founder of North Country Organics. This is his quote, and it's exactly right, that this is how I look at overseeding. We don't stop and think that one grass plant, right? So turf is the whole system. The grass plant is the individual plant. That individual grass plant only lives for 1 year, maybe 2, 1 or 2 years, somewhere in there, and then it dies. The whole sustainability of a turf system is the fact that we're constantly growing new plants through tillering or rhizomes. Are the 2 ways that we can do it in cool season. Down south, we got stolons, but we don't have it up here unless we're doing golf course greens. So, the idea that grass is aging, it's got a terminal fixed span of time, and then it's going to die. So our focus is to have a healthy system that constantly can regenerate itself. Overseeding is the way we can jumpstart that, and we can stimulate that. So some organic people will tell you overseed, overseed, overseed. You have to overseed every year all the time. I don't believe that. I think that if you overseed aggressively for the first 2 years, after that, hopefully you can concentrate on growing the plants that you have in place. Compaction, absolutely the biggest enemy of turf grass. So my focus, first thing I do is walk out in the middle of a yard or a soccer field, a football field, wherever I am, and I take a screwdriver and I jam it into the ground. I don't need my $3,000 penetrometer with me to tell me that if I can only get my screwdriver in 1 inch, I've got a problem. And I teach homeowners and tell them, to do the same thing. If I can push that screwdriver in 5 or 6 inches, well, then I reasonably have good structure with oxygen in there. But again, cultural practice wise, this is the most important. And if I have to work within a budget and manage things, I would most often sacrifice a nitrogen application in order to have the money to include aeration if I felt that it was really compacted and it was that important. If we can aerate every year as an upsell with our businesses, that's great. That's revenue. If we can't, at least during that first year, immediately prior to a fertilizer application, to get some of that fertilizer right down in the rhizosphere, very valuable practice. Very important concept here. Roots grow in the pore spaces, in those spaces that contain oxygen. Just like on that left, you've got oxygen coming in, carbon dioxide cycling out. On the right, you have a compacted soil, oxygen's bouncing off. You can see down in the gray area there, carbon dioxide is trapped as CO2 traps. That becomes anaerobic. Now, the good biological life has gone dormant. It's gone into cyst and protecting itself because of adverse conditions. The bad guys are beginning to grow. Alcohol is being produced. 1 ppm alcohol can solubilize a plant cell. So in a compacted soil, you can get 15, 20 ppm alcohol and other compounds that are actually dissolving the root systems of the grass. So oxygen, critically important. So this is a picture of a soccer goal. Anybody who's been around sports has seen that, very common. But compaction equals starvation, dehydration, and suffocation. Nothing that we do that will have any lasting effect on that system until we reverse compaction. We can fertilize. We can see that the herbicide was put down here because there's clover in the back of that goal mouth and in the back of the goal, and there's none out front. So all we've done is killed some weeds, but nothing's going to have any lasting effect until we solve that problem. So compaction directly translates to weeds, drought intolerance, and lower energy reserves. All of these statements are true. And if it's an athletic field, you know, compaction industries go up. But for us, it's weeds, it's lower energy, it's not having a healthy plant. So we're, you know, looking at it from that perspective. So let me just run through a few pictures here. You know, I can talk about this and I can say that it works, and you know, people always, will understand that, but then there's always something that says seeing is believing. So I just threw together a few pictures from a wide variety of different projects, not to tout the projects or anything like that, but just to show that it can be done. What you're looking at there is a school. It's a softball field. It's a field hockey field. It's recess. That has been organic now for, 14 years, 15 years. Synthetic fertilizers, pesticides, all removed from these equations. These happen to be a collection of public properties. As you can see in the close-ups, that they're broadleaf weed free. We're embracing a different strategy. Education, again, I can't stress enough, really getting the education from people that have done it. Understanding new products and how they work and what they can do for you. Searching out, you know, the real product from the fakers that are coming out there, and people send me labels all the time, to look at. And a lot of times I have to go back and say, yeah, just steer clear of this because it's really not, going to be doing much for you. Attention to detail. I can't stress enough, whether it's a 5,000 square foot lawn or it's a large property. Attention to detail. It is a transition process. Transition happens when we move from conventional to natural. Conventional means chemical intensive. There is a window of time necessary. New practices and product inputs change. Equal focus needs to apply to turf and soil. Length of time is determined by an individual site analysis and the existing condition of the turf. Soil condition and health, turf density, existing weed pressures or the lack of, and again, education. We're educated in conventional management, so we'd be hard pressed to think that we can just jump into natural management without at least getting some education. My threshold benchmark is 3 to 5% weed pressures per acre, and most people that I talk to agree that in this day and age moving forward, that should be an acceptable metric. You have to understand that the expectations that we have for that Better Homes and Gardens lawn were created by an industry in 1950 to sell us product. That monoculture of grasses, that synthetic fertilizers and synthetic herbicides began to give us in the 1950s. That expectation that all of a sudden clover was a good guy and now it's a bad guy, that was an industry created expectation, and we've been following that for 75 years. And look, where has it gotten us? So we're in sort of a turning point here of moving forward, having a beautiful landscape, but having a realistic expectation. Here is one of my large estate projects down in Connecticut coastline. And this is what a turf system looked like coming out of the winter. It was a 2-year-old system, and you can see there was issues in here. And the first thing we did was clean it, and we had it looking like that in 3 weeks. Simply a little bit of 3% nitrogen, but it was really soil, biological food, and grass seed. And we got from where it was to that, before we jumped into a big weed issue. Initial cost of an organic program depends on site considerations, soil conditions, expectations. If we have a soil that's really challenging, it's going to cost more to get that into good shape than if we inherit a soil that's already in pretty good shape. So we're not looking at just one cost of a program. We're looking at a multifaceted approach towards program development. Another set of expectations. This is just early spring, cool season turf grasses. It's weed free. It meets that expectation. It's nothing special. It's not perfect. But for this municipality, this was great. It met their expectation. Here's another one on a residential landscape. This was one that, we constructed from, basically the woods. All the woods encroached all the way. It was just all weeds and stuff at the edge, and we sort of reclaimed, got rid of the grass that was encouraged moss underneath here. There's all moss in the grass. That was part of the aesthetic, and we kept it. So that's a different client's expectation, on that. Again, doing the highest profile of sports, residential property here, nothing special, 1,000 square foot lawn. This had been under an organic program for 4 years. Things had really started to click. Everything here, 3-inch height of cut, maximum density. This was a bluegrass monoculture, and this was managed at just 2 pounds of N, 1,000 square feet, and all the rest was biologically focused. So managing bluegrass at far lower than what the industry would typically do. Here's another expectation: NCAA soccer field in California, crazy high expectations. And another one of my projects, AA professional baseball, 98.6% sand. We've been organic now here for 2 years. And we were just there yesterday, and we're getting ready to, begin year 3. So, we can have expectations that can be low, medium, or high, and we simply match the cultural intensity, to do it. The proof is in the finished product, that we can look at some of these being 20 years organic, and the systems are still going strong. And then here is one, a historical society in a New England town that wanted a lawn, little bit of clover in there, doesn't bother them. That's part of the aesthetic that they wanted, a natural landscape. But, we're not overrun with broadleaf weeds. And this is probably 10 years organic at the time of this picture. And this is a picture I put in here for Rick, and he's spot on that we don't have to have grass everywhere we go. The idea that alternative plant material in many landscapes can be the most appropriate. This is a botanical garden down in Delaware that I worked on for 3 years. And you can see there's a pond in the background. Over to the left is the grass. And we don't manage that grass. We do the best that we can, but all the focus is in preserving all of this. So the idea that there is too much grass in the world absolutely is legitimate. Grass is always going to be around. It's got its use and it's got its function, and it will always be here. The bottom line is that we should reduce and eliminate in some places, but in those areas that we can't, then we need to learn how to manage naturally.
Chip, that brings me to a couple of the questions in the chat box. Rob would like to know, if a landscape has been using chemicals for a period of time, can you stop immediately and go to organic, or would it be better to slowly stop in order to not cause an outbreak?
I'm an advocate for just stopping. It does with fertilizers. It doesn't work to have a slow withdrawal. You have to have the confidence that organic fertilizers are going to work, and they do work. The difference in the two fertilizers is that synthetic fertilizers mimic what the plant can use. So when we understand that the plant can use nitrogen in one of two forms, ammonium or nitrate, that's the two forms, the NO3- and NH4+. So we went to a laboratory all those years ago to create synthetic versions of that work immediately. Organic nitrogen cannot be used by the plant. Organic nitrogen that's contained in organic fertilizers has to be broken down by the bacterial fraction of the soil. We have to start that and get that going. Now, in rare circumstances, I don't have that. One of the advantages of extensive testing is if I don't have enough bacteria to break down organic fertilizer, then I'm going to go to a transitional product that's going to give me some solubility and some organic, or I'm going to stay all organic and use sodium nitrate. That's salt. So that's another mineral salt, but it's an organic mineral salt, not synthetic. But yeah, the message in my experience is that I don't generally wean. I just jump in and do it. But if I have to, then I have all these defined, parameters where if we are moving forward and something goes off the rails, I'm not going to wait till it gets to be a problem. Then if I need more soluble nitrogen, then I would do that. As far as pesticides go, it's almost one of those things you're either all in or all out. And there's no you can't use a synthetic pre-emergent and successfully overseed and thicken a lawn in the spring. The two just don't go together. So, then it becomes the question, what are the client's expectations? Do you use, now there are situations where the recommendation has been, okay, we're going to be all organic, but you're going to use a pre-emergent for 1 more year, so that as you are transitioning the rest of the system, you're not fighting an explosion of crabgrass. But that only holds true if you know that you have a property that has a history of significant crabgrass issues. But for the most part, if pre-emergents have been done for a number of years, theoretically, right, there shouldn't be a lot of crabgrass seed left there to become an issue, because it should have all germinated and then killed. The germinated seedling should have been killed over a number of years, and all you might be experiencing would be crabgrass seed that blows in. But if we focus on rapidly building turf density through proper nutrition and overseeding, that's going to take the place of a pre-emergent. So my first choice of a pre-emergent is a bag of grass seed. So I'm sort of the one that I really want to stop the other practices and begin, a natural program.
Is there a better time of year to start that?
You could start, I probably, of all my projects, half of them probably begin in the spring, and the other half of them begin in end of August, early September. And, we're taught that March, April is the beginning of the grass growing season. But I've always said that in my mind, the beginning of the real grass growing season is Labor Day, because fall, everything with fall and the genetics of the grass plant line up to be the perfect conditions. So I love beginning a program in September and using the fall to set the table for what's going to happen in the spring. And I look at my April program as a continuation of where I left off in the fall. But you could begin either way.
There was a clarification. Was that 2 pounds of nitrogen per season, all season?
2 pounds of nitrogen per 1,000 square feet for the whole year.
And can you tell us a little bit about some national parks that you've been managing?
Yeah, at one point I worked with the National Park Service, and we were doing about 12 of them. We did, Central High School in Little Rock, Arkansas. We did Herbert Hoover's birthplace and burial site. That was one of the most successful. In Iowa. Oh gosh, we did, I can't think of all this. It was a while ago. That was an initiative that was about 10 or 12 years ago. And then there actually has been, they are just in the process now. And it's funny, the National Park Service, it went all the way up. I'd go down to Washington, meet with the powers that be, and they were all about sustainable turf management and moving forward. And then, like a lot of different projects, a new regime comes in, And right now, the regime that's in there, that's in control, is very chemically oriented. But they're actually working on finalizing a document that I co-authored that talks about, natural turf management strategies to improve the health of parks throughout the park system.
Fantastic. And I think we've got some specific property questions that might need to be unmuted to ask. But meanwhile, there is a ongoing chat that maybe you can enlighten us about. That John says after aeration, he uses a product from the Andersons called Black Gypsum DG. And he says he has amazing results after 2 seasons.
Yep, I don't doubt it. Legitimate product with distinct benefits. Yep.
Fantastic. And if we could get the host to unmute, I will let the homeowner that is on this webinar ask the specific questions about his new home development.
Everyone's able to unmute themselves.
Okay,
we
so
can
if you
ask
want to
questions,
unmute
go
and
right
ask
ahead.
the questions.
Let me chime in here for a moment, since I have a lot of experience in that new homeowner area. Builders typically absolutely pay no attention to what they dredge up from the foundation excavation. They love spreading it all over the place. They don't care if it's subsoils, rocks, or whatever. And then the landscaper comes in and top dresses with 1, 2, 3, 4 inches of soil. Generally speaking, most new construction in some of the areas I've dealt with have been nothing but a problem soil texture wise. Anybody want to comment on that?
That's absolutely true. I just finished last year engineering a project for $450,000 that we tore out 58,000 square feet of grass and soil down to a depth of 8 to 10 inches and replaced it all, because exactly what you described is what the general contractor left. And then they came in when they soiled out the property, and I had between 2 and 4 inches of soil over foundations of barns and building debris and compaction and everything else. So there is no guidelines in the industry. The construction industry just views soil as dirt, as another medium. It could be rocks, it could be clay, it could be sand, it could be soil, but they don't look at it as a living, breathing, group of organisms, nor do they take into account that you need more than 2 or 3 inches to grow a good lawn. So what happens is they build the landscape.
Chip, you're muted.
Chip, you got to unmute yourself.
Oh,
Somehow
sorry. No, I hit my pad. What I was just saying, that the contractors come in, they don't understand that it's living, breathing. They throw a little bit of soil, jack it up with synthetic nitrogen, and kill a few weeds with pesticides. The lawn lasts for 2 years, and then it collapses because it doesn't have the resources.
To further comment on the soil structure and texture in those situations, there's also an adverse effect on drainage when you end up putting differential soil textures in cahoots with themselves, in particular overlaying a sandy loam on a clay or other compacted base. You will generally have a problem with soggy turf over time. And the problem is, when you irrigate, you end up making the soil worse, because any irrigation tends to stay in that loamy profile.
That's correct. That's correct. You get a definite stratification, and roots, they grow through the top part of the profile, and then they just stop and shut down, and they grow horizontally, because then that's a very unhealthy situation.
I'll go ahead and ask Matt's question. It says, and maybe you've completely addressed it, or maybe there's some other inputs you can give, but his question is, what is the best thing to do with newly developed homes with very poor soils if you can't top dress with compost? And what is the next best technique or input to turn the soil around?
Well, I mean, in some cases you can, and in some cases it's not so much about the quality of the soil, is it about the way it's constructed and what there may or may not be for underlying levels of compaction, just as it's just as we were just talking about. That's as much the problem as a poor quality soil. Then when you talk about what makes a quality soil, well, it's the organic matter fraction, it's the balance of chemistry, it's the relationship of sand to clay, and what do we get for drainage versus what do we get for nutrient retention. So if you can't compost top dress, the best way that I've found to improve poor soils is through the use of some type of a humate. Whether it is a liquid humic acid or a granular humate. And if I'm looking at it as I'm more surgically targeting the humic fraction of organic matter. When I showed that slide with the 3 circles, the texture, chemistry, and biology, and the interactions there, the overlapping that made soil health, humus is largely responsible for that part of the reaction. So anytime I can, surgically target the humic fraction of organic matter to try to make the plant as healthy as I can, and then, through cultural practices, aeration and introducing as much new turf as possible, along with proper nutrition, is try to change soils slowly over time. There's no question that when you're moving through transition, especially with poor soils, that if you have a budget, a good budget, you can move more quickly and more effectively towards the end goal. If you don't have the resources to do certain practices, or you don't have the budget to do certain practices, you can still generally get there, but it's going to take longer. And then, I've had soils where there's not a whole lot that you can do. And, if I always tell, service providers that if you get onto a, homeowner association, condo complex, new development, first thing you want to do is take a shovel and stick it in, see how far you can dig a test pit. Otherwise, and identify underlying construction issues, because if you don't, and you're on that job for 3 or 4 months, whether they preceded you or not, you're going to own it. And, put up front that I got an issue here, and, there's my budget, but I can't change what somebody else did. So the bottom line on that is you can't always make positive changes in reasonable time with reasonable budget.
Okay, we have Stephen asked a question. Is Seaside Park ball field in Marblehead native soil?
Yes, it is.
Okay. And what about San Antonio River Authority, William? Okay. And we've got a question from Ed. How do you feel about Tenacity for post-emergent?
Tenacity is rescue treatment. It is not organic. It's not part of an organic program. It doesn't fall under a definition of an acceptable material under organic landscaping standards. That being said, it is, relatively low impact, meaning low mammalian toxicity. It's got a really quick half-life, like 12 hours. You can't use it. It's got a groundwater label. So in high water table or any proximity to surface waters, it's not allowed use. But if there is a, in NOVA, in Connecticut NOVA, Organic Land Care Standards, we have written in there what we call a rescue treatment. We have organic compatible rescue treatments and then non-organic rescue treatments. And Tenacity would fall under the non-organic rescue treatment. And the way we define it is that you have a problem, you haven't been able to take care of the problem any other way. So Fiesta would be a first choice before Tenacity for selective post-emergence. And if that didn't work, then you're stuck. Then potentially you could make the case to go to Tenacity, but you document the issue, you document the steps that you've tried to solve it. That didn't work. So now you're going to use this. And as long as you have a legitimate organic plan after the fact to come in and work to further change that system so that you don't become reliant on repeat applications of Tenacity, in that light, you could use it as might be needed. And again, as long as the client realized that you were forthright with them that they were not getting, it was a non-organic treatment, but you were recommending it, for whatever reason you were doing, but certainly not trying to present it as organic.
John would like to know what your take on processed cow manure as an organic top dress is.
Too much phosphorus. So we're really not trying to use much manures anymore. I don't even use composts anymore that have manure as a feedstock. I really want my compost. I work in the field of composting. I consult in the compost industry, gone to school for composting, and I'm looking at sourcing compost where phosphorus is 0.4% or less, 0.4, maybe 0.5. Manures are higher. They're up at 2s and 3s. So it grows great grass. Believe me, I top dressed with dairy manure 20 years ago, and I top dressed that Seaside Park twice 20 years ago. I put enough phosphorus in there for 25 years with 2 top dress applications. So, we learn by our mistakes, right? So,
that's a good point about the manures. I remember, quite a few years ago with the Chesapeake Bay and, all the problems from the egg laying and all that, the manures there. But they did a study and they showed that actually half of the phosphorus going in there came from the Amish farming methods, where they use manure and they did not do anything to prevent it from running off into the waterways.
Yeah, that's exactly true. I was involved in those efforts, the cleaning the Chesapeake and work in Maryland at the time, and that's exactly right. That's exactly what's happened. Yeah.
We've got
couple
more quick questions if you've got time. Barry?
Yeah,
what
I'll do a couple more.
Okay. One is about biochar. Is that effective?
Yeah, I'm really an advocate for biochar. I've been working and developing a couple of fertilizer formulations that incorporate biochar in it. Biochar, just the message on biochar, a little bit goes a long way. There's a difference between biochar and activated biochar. So you really want the biologically activated biochar. Yeah, I mean, it's carbon, it's a microbial food. Carbon drives the biomass and nourishes the biomass. So it just, in as much as humic acid and a granular humate are carbon, so isn't biochar. So yes, I think that biochar has a definite place in the landscape industry moving forward. But then again, you can put too much in, and when you get too heavy, too much, you can disrupt the system the same way you can with humic acid. I mean, we know that a 12% humic acid, the maximum load for an acre of grass is 3 gallons of 12% per acre per year. If we start to put 5 or 6 in there, we're going to disrupt the system. Same thing happens with biochar.
The last one is about the efficacy of Fiesta for Indian mock strawberry, ground ivy, creeping Charlie.
Yeah, Barry, do you want to, I mean, that's sort of your thing. I've had good luck. It's about the labeled rates that you use, and there's a variability of a labeled rate there. And I mean, gosh, you can take Fiesta at the maximum labeled rate, and it's darn close to non-selective. And, and you can do that. So then it becomes the balance of what you have for turf system and what you're looking to take out of there. But with 2 applications of Fiesta, I've had good luck, and I didn't, early on, because it was a much lower labeled rate. The thing with Fiesta, we understand, is when it first came out, and Barry remembers this, the labeled rate was 7 ounces a gallon and then it went up to 8 or 9, and then and every time they went back to the EPA and appealed for an increase in the labeled rate. And now where labeled rates are established, they work at these labeled rates.
Yeah, and
But
there's
like,
a couple of things you can do to improve the efficacy. If you add a little bit of yucca as a surfactant,
Yep.
Some fulvic acid to actually pull it into the plant better. So you can boost it up that way.
yeah, good.
Just a quick note too, if you haven't gotten it or you're curious about organic land care standards, Richard was kind enough in the chat to put a link to the standards themselves to learn more.
Right. So Chip, you did exactly what I hoped you would do. and you focused on soil and soil health and the microbiology. Here at Terra, we do have a lot of products that we get out there, and I always try and get people to start with the soil and the microbiology. But the overall mindset is, no, we need the control products. Well, I can give you softer chemistry for that, but you still got to focus on the soil. And it's something we always try to drum into people's heads. And it's, the landscape industry has never thought that way up until the last 10 years or so. So it's a process.
It is a process, and we're beginning to think what I say a lot of times, we're thinking beyond NPK. Where in the past we focused on NPK, agriculture focused on NPK, everything was focused on NPK. And once we realized that we can embrace the concept of less is more and move into other things beyond simply having to rip open that fertilizer bag and put it down, the end result is a stronger, more resilient system that, basically will give back to us over time.
Yeah, and I do see our industry moving more and more in that direction, slowly, but there is definitely a movement, and it comes from regular people, not so much the landscapers, but it's people who are more concerned about their health. Yeah. And doing things the right way. So unless there's anything else, anybody else have something? I need a few more minutes to talk about a little bit more about Chip, but if there's any other questions, let's have them.
Nope, the questions are all, everybody's gotten asked. So I think we did a good job covering it. Thanks.
Okay, so again, Chip, thank you very, very much. An hour and 20 minutes is not enough of you. And
or too much, you never know.
Well, it depends on the day.
There you go.
So we did have Chip signed up to do his 2-day course down here in New Jersey, and unfortunately due to COVID we had to postpone that, and we are really hoping that we can get you back down here, next winter, this coming winter. And anybody going to Chip's 2-day course comes out of there a changed person. So let's hope we can do that.
Right.
So thank you, everyone. We will be sending you a survey to, give us feedback on what you thought was good, what wasn't bad, and what other subjects you'd like us to cover. As much as possible, we want to make this an ongoing series of webinars where more and more people can learn how to have a better environment and be safe in your own yards. So again, thank you, everybody, and we will be in touch.
Thank you all. Nice to see everybody.
Thanks, Chip. Have a good night,
You're
everyone.
welcome. Thanks. Take care.